Close your eyes for a moment and picture the year 2070. What do you see? Flying cars, cities in the sky. While those are staples of science fiction, the most profound revolution might be happening right beneath our feet, completely unseen. It's a revolution that powers our world silently, cleanly, and almost endlessly. Welcome to the future of energy, a future powered by the very heart of our planet. For centuries, we've looked to the sun, the wind, and the water for power. We've drilled deep for fossil fuels, releasing ancient carbon into our atmosphere. But what if the ultimate energy source has been right here all along? I'm talking about geothermal energy, the immense, primal heat radiating from the Earth's core. Now, I know what you might be thinking. Geothermal, isn't that just for places with geysers and volcanoes, like Iceland or New Zealand? That's been the traditional view. But the geothermal of 2070 is a completely different beast. What we're talking about is a technological leap that makes geothermal power accessible not just in a few geological hotspots, but almost anywhere on the planet. Imagine a world where entire cities are powered by the steady, reliable heat drawn from miles below the surface. A world where energy is no longer a source of conflict or pollution, but a universal, democratized resource. This isn't just a dream. It's a future that scientists and engineers are building today. So, how do we get there? The journey to 2070's energy landscape begins with understanding the problem with traditional geothermal. For a long time, we've been limited to hydrothermal systems. These are rare spots where underground water is heated by magma and can be easily tapped for steam to turn turbines. It's efficient, but it's like only being able to fish in one small corner of a vast ocean. The real treasure, the vast majority of Earth's heat, is locked away in hot, dry rock deep underground. The key to unlocking this treasure is a technology called Enhanced Geothermal Systems, or EGS. Think of it as planetary-scale geothermal engineering. Instead of looking for naturally occurring hot water, we create our own geothermal reservoir. The process is fascinating. First, we drill deep. I'm talking to 3, maybe even 5 miles down into solid, hot granite or other rock formations where temperatures can exceed 400 degrees Fahrenheit. That's more than hot enough to bake a pizza, or more usefully, to boil water. Once we reach the target depth, we inject hypersure water to create a network of tiny, new fractures in the rock. This is a highly controlled process, guided by advanced seismic sensors that map the fracture growth in real time. It's like creating a circulatory system for the Earth's heat. This network of fractures becomes our man-made reservoir. Next, we drill a second well, an extraction well, into this newly created reservoir. Cold water is then pumped down the injection well. As it flows through the network of hot fractures, it heats up, turning into superheated water or steam. This steam is then brought back to the surface through the extraction well, where it drives a turbine to generate electricity. And here's the beautiful part, it's a closed-loop system. The water is cooled, condenses, and is sent right back down to be reheated. No emissions, no fuel, just a constant, clean cycle of power generation. By 2070, EGS technology has become incredibly sophisticated. The drilling techniques, born from decades of innovation in the oil and gas industry, are now faster, cheaper, and more precise than ever. We're using revolutionary drill bits made of diamond composites and powered by plasma torches that can vaporize rock, allowing us to reach target depths in a fraction of the time. Imagine drilling a 5-mile hole in a matter of days, not months. But the real game changer is the use of artificial intelligence and supercomputing. In the 2070s, AI algorithms analyze vast amounts of geological data to pinpoint the most promising locations for EGS plants. They predict how the rock will fracture with millimeter accuracy and continuously optimize the flow of water through the reservoir to maximize heat extraction and energy output. This level of precision and control makes EGS not only powerful but also incredibly safe and reliable. One of the biggest advantages of this next-gen geothermal is its tiny footprint on the surface. Unlike sprawling solar farms or vast fields of wind turbines, a geothermal plant that can power a small city might only occupy a few acres of land. The bulk of the operation is deep underground, silent and invisible. This means we can preserve natural landscapes and use valuable land for agriculture, housing, or rewilding. And let's talk about reliability. Geothermal energy is the ultimate baseload power source. The sun doesn't always shine, and the wind doesn't always blow, but the Earth's core is always hot. Geothermal plants can run 24 hours a day, 7 days a week, 365 days a year, providing the kind of steady, dependable power that modern grids desperately need. In the 2070s, geothermal provides the stable foundation upon which a grid, powered by intermittent renewables like solar and wind, can thrive. It's the anchor of the clean energy system. The applications go far beyond just electricity. The residual heat from geothermal plants is used for district heating, warming entire neighborhoods and business districts. It provides hot water for industrial processes, powers greenhouses to grow food year-round, even in cold climates, and even drives desalination plants to create fresh water from the sea. It's a holistic energy solution where every unit of heat is put to good use. This concept is known as geothermal cascading, and by 2070, it's a standard practice in urban planning. Let's visit a hypothetical city in 2070. Let's call it Veridia, located in what used to be considered a non-geothermal region, maybe somewhere in the American Midwest. Underneath Veridia, a network of EGS wells silently hums, providing all the electricity for its 1 million residents. The streets are quiet, filled with electric vehicles, all powered by the Earth's heat. In the winter, homes and offices are warmed by hot water piped directly from the geothermal plant. The city's vertical farms, which provide fresh produce for the entire population, are also heated by this system. There are no smokestacks, no air pollution, just clean, sustainable living. This future isn't just a Western phenomenon. By 2070, geothermal technology is being deployed across the globe. Developing nations are leveraging EGS to build robust, independent energy grids, leapfrogging the fossil fuel era entirely. It's a powerful tool for energy independence and economic development. A small, portable EGS unit, perhaps the size of a few shipping containers, could be deployed to power a remote village, bringing electricity for schools, hospitals, and businesses for the first time. Of course, the road to 2070 wasn't without its challenges. Early concerns about induced seismicity, small tremors caused by fracturing the rock, had to be addressed. But with advanced monitoring and AI-driven control systems, the process became as predictable and safe as any other major construction project. The upfront cost of drilling was also a hurdle, but government investment and economies of scale eventually made geothermal competitive with, and then cheaper than, all other forms of energy. So, as we look out from our vantage point in the present, the vision of 2070 is clear. It's a world that has finally learned to work in harmony with the planet. We've stopped burning our home to keep the lights on and have instead tapped into the clean, perpetual furnace that has been glowing beneath our feet all along. The future isn't about finding a new planet, it's about learning to live intelligently on this one. And the key to that future is the incredible, untapped power of the Earth itself. The geothermal revolution is coming, and it will change everything. Thanks so much for watching. If you're excited about the future of clean energy, don't forget to like this video, subscribe to the channel, and hit that notification bell so you don't miss our next journey into the world of tomorrow. What technology do you think will define our future? Let me know in the comments below. See you next time.